Okay, example 7, a ball is thrown vertically upward with an initial velocity of 48 feet per second. If the ball started its flight at a height of 8 feet, then its height s at time t can be determined by s of t equals negative 16t squared plus 48t plus 8, where s of t is measured in feet above ground level and t is the number of seconds of flight. Okay? Basically, the gist of that is here is an equation representing the height of the ball. This is the height of the ball at any given time t. All right, t is the number of seconds after the ball is released. We have somebody throwing it in the air. They let go of it. They're taller than I am, but when they let go of it, it was 8 feet above the ground, and 48 feet per second was the velocity they threw it at. This is actually based on Earth's gravity. This is an actual equation based on the gravitational pull of Earth. It's 32 feet per second squared is the gravitational pull of Earth. You always do half the gravitational pull times t squared, initial velocity times t, initial starting position, to create a position function involving, what's the word I'm thinking of? No, some type of motion. Can't think of the word off the top of my head, dang it. Okay, anyway, but motion due to gravity. You know, if you throw something, even if you're throwing it straight up or if you even throw it out there, gravity is pulling it down 32 feet per second squared. The initial velocity in a vertical direction is going to be decreasing based on gravitational force. Eventually it pulls it back down to Earth. Okay? This represents how high the object should be at any given point. It's easier to throw it straight up in the air because we don't have to do any sine, cosine stuff to determine the velocity going that way was 48. So the vertical velocity was this, the horizontal velocity is that. So we're going to be throwing stuff straight up in the air right now. We get to trigonometry, we might start throwing them at some angle, make it a little more challenging. All right, anyway. Questions they're going to ask about this. How long does it take to attain its maximum height? What's its maximum height? How long does it take to hit the ground? Those are the types of questions they ask. When is it going in a positive direction? When's it going up? When's it going down? How fast is it going at this moment in time? Those types of questions can be asked. That's more of a calculus question than a pre-calculus question, that last one. But those are the types of questions they're going to ask based on this. So, first off, think about a ball being thrown in the air. What happens to the ball when it hits its highest point? It stops. All right? Okay? It hits its maximum height, it stops. So if we know if it stops, then we've got its maximum height. Okay, also, if we think about this height, this is a quadratic function. So this function creates a parabola. It's got a negative coefficient in front of t squared, which makes that what it looks like. And if you actually throw a ball like that direction, it creates a parabola. Just naturally, it creates a parabola because its height is determined based on the force of gravity, and that's just that. Ours is not actually traveling this way, but we're demonstrating as time passes, the height changes, and eventually it hits the highest point here, which is the vertex. So the question is, determine the time it takes to the ball to attain its maximum height. Notice t is acting as the x-coordinate, s of t, the height, is acting as the y-coordinate. So our formula for finding the maximum or the vertex value is always the vertex value of x, right? In this case, we're going to use t. So for part A, the vertex value of t is going to be negative b over 2 times a. So b is positive 48, so negative b, negative 48, 2 times a, 2 times negative 16. That just makes 48 over 32, which divides out to 1.5 seconds. So if you throw a ball in the air with an initial velocity of 48 feet per second, it will stop exactly 1.5 seconds later. Okay? That's just how gravity works out on Earth. If you're on the moon, it would take a lot longer. The moon's gravity is less than Earth, like 1.6. I think it's 3.2 meters per second, or feet per second squared, so it'd be negative 1.6 there maybe, or something along those lines.
Mine was 1/6 of Earth's gravity.
Is 1/6?
Yeah, 1/6.
So that'd be about 5.4, so half of that 2.7, somewhere in there. So it would take longer, okay? That's all you need to know. So we're going to be probably doing stuff on Earth in this book, but just know that if we go to a different planet, it changes. All right. That's how long it takes. So determine the time it takes the ball to attain its maximum height. Answered. Done. All right. Again, making sense of the variables. One other thing I'm going to mention that some of the students in the past have had trouble with in this chapter and also last chapter with the word problems. Almost every word problem says, here's an equation, this is what the letters mean. And they're very wordy about it. You know, they talk about all the stuff and why it leads up to this and all this other thing. What you need to get out of it, the information you really need to pick out of each of these problems, find me an equation and tell me what the letters in the equation represent. That's what you really need to get out of it. All right? They might describe what happened, you know, the ball's thrown vertically in the air. Give me an equation, tell me what the variables represent. All right? And then I can answer the questions based on that. So really focus on that when you're reading. Okay, for part B, it says determine the maximum height the ball attains. Maximum height is the height of the vertex, right? Which is the S of t value here, right? So to do part B, I just have to do S of 1.5. I wouldn't be able to do problem B if I didn't do problem A first, right? So if they didn't ask that part A, they just said, how high will the ball go? Know that you have to find out the maximum x coordinate to find out the maximum y coordinate, okay? S of 1.5 is going to be negative 16 times 1.5 squared, which is 2.25, plus 48 times 1.5, plus 8, 32 plus 4, so negative 36 for that, 48 plus 24 is 72 for that, that's 44 feet. The ball should go about 44 feet in the air. Those will be the most typical questions they ask you about this, okay? If you're throwing stuff in the air. How long did it take to stop? How high was it when it did stop? Okay. Part C is the other question they tend to ask in this class. When does the ball hit the ground? Determine the time means when, right? All right. What's true about the ball as it's hitting the ground?
It's height is 0.
Height is 0. All right, and that's what you want to get out of it. A lot of times people say it stopped again. Velocity 0. As it's making contact with the ground, it's actually going fast. Okay? In fact, it's going to be going a little faster than it would have gone to begin with. But again, that's calculus. When they ask about speed, that's calculus. We'll deal with that in calculus. Anyway, but determine the time it takes the ball to hit the ground. Hitting the ground is the height of 0. Height is S of t. So they're letting S of t is equal to 0, equal to the quadratic function, negative 16t squared plus 48t plus 8. Now, chances are that won't factor. It won't factor easily if it does factor. So I would probably go directly to the quadratic formula. Before I did the quadratic formula, though, I do notice all three numbers divide evenly by 8. This is not required. But the smaller numbers are here, the smaller numbers you have to work with in the quadratic formula. The other thing for me personally, I'm trying to leave squares off today in videos. Anyway, for me personally, I like my square term positive, so I would probably even go one more step and move everything to the left. So positive 2t squared minus 6t minus 1 equals 0. You don't have to do that. I like it better that way. All right. So if I get to t equals, right, I got my quadratic formula structure set up, minus b goes there. If I'm using this equation, quadratic equal to 0, b is negative 6, so minus b is positive 6. 2a is going to be 4. B squared minus 4ac is going to be positive 36 minus 4 times 2 times 1. That comes out to 28. Okay. I want to get decimal approximations for this, so I'm going to use my calculator. I'm going to type in my calculator first.
Is it negative 1?
It is negative 1. Thank you, PJ.
I was going to say, because it should come out.
All right, so then that'd be 44 instead of 30.
Yeah, 48.
Instead of 28. All right, thank you. So we should get 44 here. All right. So I was looking up here instead of, so b squared, positive 36, 4 times a, 2 times c, negative 1. 2 negatives make a positive, 8 plus 36 is 44. Okay. So what I want to do is I'm going to type in the square root of 44 on my calculator, which is 6.6332. And to get my times, I'm going to add those numbers over 4 and subtract those numbers over 4 and then divide by 4. Okay. you can actually just get them in your calculator, but just to be safe, if I do 6 plus 6.6332, I get 12.6332. If I do 6 minus, I get negative 0.6332. Divide both numbers by 4, I get 3.16 seconds. And I also get t equals negative 0.16 seconds. All right, so consider these answers that we're looking at here. I'm going to go full page so we can kind of look at everything at once. Okay. Going back to problem A. Time it takes to reach its maximum height, 1.5 seconds. That's just the x-coordinate of the vertex. How high does it go? Evaluate the function at the vertex. That's how high it goes. I think it's coincidental that this came out with the same number as that. Don't imagine that's going to happen all the time, especially if I kept the numbers big here. It obviously would have been 44, right? Okay, look at these times here. Which one do you think is more important?
3.16.
Why is that?
Because you can't have negative time.
Yeah, negative time represents before this thing even happened. So if you look at it, ever look at time equals 0. The reason time equals 0, it's not on the ground, is because the guy let go of the ball 8 feet above the ground. All right. So the ball's starting in the air. It's representing, this negative 1.16 seconds represents to reach the exact same height. If the ball had started on the ground, I mean, you would have to have a bigger velocity to get up to this point. So from the point it started to here where you let go of it, it got to 48 feet per second there. Okay, so that's what that represents. So we throw that one out. Typically you get one positive, one negative. Sometimes if it starts on the ground, 0 and the other number is the one that counts because 0 is when you started. When it's hit the ground, it implies after the ball went up in the air and back down. So you're looking for something beyond 1.5 seconds. So take the bigger number in that case. If both answers make sense based on how they asked the question, when was the ball on the ground? You know, then you could. This one was still that because it wasn't on the ground there. It started in the guy's hand. So keep that in mind. But those are the types of questions that come up with that. So just be aware of that and be able to answer those questions. But again, the main idea for all the word problems, here's an equation, here's what the variables represent. Look for that in the words, or if it goes back to the profit and revenue stuff, know how to create a profit function, and they'll give you enough information to establish revenue and cost. They might even give you stuff, cost function, revenue function, whatever. They gave you price per ticket at least, so you could determine a revenue function. So use the skills we've done in this class, also draw on information and stuff you've gotten off all your other classes. And really think through the problem before you give up on them. All right? I've had students give up early. The more you think, the better off you're going to be.